Tangent. Sine divided by cosine, right? So, well, I don't even need to do this. Sine divided by cosine. What's this value divided by its negative self? -1, okay? So tangent of 135. Folks, here's the day that you got to be patient. If you get all this stuff, hot dog. I'm so happy for you. Some of us don't, so you got to just chill out, and you got to be patient. And you have to use some self-control rather than rolling your eyes or huffing and puffing. 60 degrees. 1/2 √3/2. And I need the tangent of 60, which is sine divided by cosine. You with me on this? Did you get √3 for tangent of 60? You got -1 for tangent of 135. Very good. Here we go. Now, you use different formula. So you would have had tangent of 2. Nope, my fault. Card. Somebody hand me a card. Tangent of who? Tangent of 135. Where are we? There we are. We're addition. Tangent of 135 plus tangent of 60 over 1 minus tangent of 135, tangent of 60. Jansen, you with me so far? All right. Here we go. Tangent of 135 is -1 plus tangent of 60 is √3 over tangent of 135 is -1 times √3. Right on? -1 plus √3 over 1 minus. What's -1 times √3? -√3. What's minus a negative? Plus a positive. Oh, look, you got the same answer that I got.
Oh, we stop there?
You can.
I took it the rest of the way out. Yeah, took it all the rest of the way out.
All right, hold up. Before I do that, no, because remember my answer was.
Yeah.
So you know you got the right answer.
Well, see, I didn't know the answer. Because my answer was 2 minus 3. That way it took the side by time.
Okay. But when I told you, when I put this up here, I said I did not rationalize this answer. So if you have that, you know you're right. But I will rationalize it because you rationalized. First, that's okay. I got to get rid of this. I don't like to have a leading negative, okay, which is right here. I'm going to have to change the way that looks. I'm okay with the denominator. I'm not okay with that other. Are you okay with me doing that? Okay. Multiply by the conjugate. This is algebra 2, folks. Now, you got to FOIL it out. This is algebra 1, foiling. √3 minus 3. You with me? -1 positive √3. You still with me? 1 minus 3. Because you do the F and the L, right? Okay. Here we go. Combine like terms. What's √3 plus √3? 2 √3 minus 4 over -2. You down with that? Can I factor out? Y'all know, I know y'all reduce. I factor out a GCF. Okay. You all right with that? All I'm going to do with that negative, I'm going to float it to the top. Which is what I had. That's all right. You got it right. Okay? That's all right. That's all good. Questions? This is like 1/2. My answer up there, 50 over 100. That's 1/2. That's the way it should be in the perfect world. Okay? Other questions? You cool with 4? Are you cool with 8? How about 11? 11, was it 11, 12, and 13? Here we go. Be patient. cosine squared x minus tangent squared x over sine squared x equals cotangent squared. I get the fact that this is driving some folks crazy because there's not one perfect way to do this. I understand. I really do. I'm not saying my way is perfect. You may not understand the way I'm seeing this problem. That's okay. You need to do the problem the way you see it, and then you need to come to me before school, during lunch. Well, you can't come during lunch unless you have second lunch. And then I will try to help you, okay? But there's not one perfect way to solve these problems. There are lots of different ways to solve this. This just happens to be the way I solve this problem, okay? Are you fair? Is that fair? Okay. Pardon? Probably. You want me to solve? I will. How did you begin solving it? All right. 1 over cosine? Yeah. Oh, there you go. Ding, ding, ding. You want me to finish it? All right, so, and see, that was the part. I had one person that put, for the tangent value, they put 1, and it should have been -1, and they went, are you kidding me? So it made everything wrong. Can one tiny little problem make you get the whole thing wrong? Yeah, it can. And that's what you just kind of go, ugh. Okay? All right, here we go. If I'm working this right side, then that means to me, I'm going to have to get like denominators, right? So I'm going to have sine squared x cosine squared x minus, same thing. Which means what's going to be up here on top? Sine squared x. And what's going to be up here? Cosine to the 4th, right? Okay, ooh, ooh. All right, we can do this. We can do this. I got to get that. Do what? Fractions are awesome. I want to smush it together. This is what some people asked me about earlier this morning. Cosine to the 4th minus sine to the 2nd. Folks, what is that? That's a difference of squares. That's a difference of squares. You've got to be able to recognize that. I can't do that for you. At some point, it's got to click, and you go, oh, I see it. Okay? Cosine squared x minus sine, plain old sine. Cosine squared plus sine. Ooh, ooh, ooh. Oh, Lord, please let this work out. Okay? Okay. What now? Ah, what now? What are you seeing? This is as far as you got. So y'all worked out the left side or the right side first. All right, how is that working out for us? Not too good. All right, so what I'm going to try to do now is I'm going to go, okay, all right, I'm all right with that. Let's just see if I started working on the left side, can I make my left side match one of these sides? Are you down with that? Okay. All right, so let's see. What am I going to do with that beast? I'm going to split it into 2 fractions. Why? We talked about this yesterday. Bless you if that was a sneeze. Bless you anyway if it wasn't. I can do this when, I don't mean to interrupt you, when you have a binomial over a monomial. I can split it into 2. I'm unsmushing it, okay? And now what? Well, now we just got to take care of that right there because what is cosine divided by sine? That's cotangent. Heck yes. I got one part of it right. Now I just got to make this right here look like this. Can I do that? Well, let's see. Minus. How can I rewrite tangent? I'm getting ready to go old school. Sine over cosine. Sine squared over cosine squared, right? Divided by sine squared over 1. Are you down with that? Okay. Cotangent. Keep it there. Let's keep that cotangent. Copy, change, flip. What's getting ready to happen? They're going to cancel. And I'm left with cotangent minus 1 over cosine squared, which is what, y'all? Secant squared, which is here and all the way at the top. Yay. Okay. Don't give up. Moral of the story. Number 6. What are you seeing here? Tell me some thoughts. What are you seeing? I see one thing in particular. What are you seeing, Maria? You're seeing a proportion. Even before I noticed the proportion, I noticed something else. Card, why, Tyler? What? What's that mean? Why would you be drawn to the card? You're right. As a card. What is sine squared? What is 1 minus cosine squared? It's the difference of squares. What's going to happen here? I cross cancel those, and it's going to give me 1 plus cosine x, which looks a whole lot better than that fraction that we started with. Do you agree? Now look at the left side, and let's see what we can do with the left side. Hey, what are you seeing there? Unsmush them, right? 1 over secant plus secant over secant. What? Ask it again. Yeah? Yes. Yes. Because I'm unsmushing it. If I had this, if I had like denominators, then what would we do with that? We'd put them together, right? And I would write 1 numerator over 1 denominator. Okay? I'm just undoing what I typically put together. Yes? Okay, now you're asking a good question, and I'm finding lots of people doing this. Why is it okay, side note, okay, why is it okay for me to be able to cancel this, but I can't cancel this? Why? Why, Cindy? Because what are these two doing? They holding hands. The bottom is 2. But you can't break that up. Don't be messing with my man. You can't do that. You can't do that. Don't laugh. You can't do that. And here's what I told my students. A monomial can only be canceled with a what? Monomial. A binomial can only be canceled with a binomial. This is a binomial with a squared term. This is a binomial with a not squared term. They are not the same. These, I can cancel these all day long. I agree with you there. But if it's a binomial, don't you dare do that. Cannot do it, cannot do it, cannot do it. Why? Because I said so. Don't do it. But everybody's trying. A whole bunch of folks are trying. Okay? Is that what you were asking? Yeah. Don't do it. Now, back to this left side. Y'all, what's going on here? What's 1 over secant? And y'all are the ones that told me, Luke told me this. In this class, I said, I just can't do it. And he said, well, it's just this. What is it, Luke? It's just cosine. He is my proof. He is my reason on my proof because he told me so. Luke told me that 1 over secant is cosine. Do you agree? You should. He don't lie about that. Isn't secant over secant 1? Yes. Oh, I'm closer. Can I just rewrite this 1 plus cosine x? Heck yes. You don't have to. Would be better if you did. 1 over cosecant would be sine. 1 over secant is, and I remember me going through that, and I said, I just can't do it. He said, but it's just, and I went, okay. He twisted my arm. Thanks, Luke, for being a bully. Okay? Are we good with 6? 7? 7. 7's going to be a fun problem. It's not that bad. Let's see, cosine squared over 1 minus sine cosine secant minus tangent. All right, are we cool? Whoo, we got some stuff going on here. Immediately, now this is just the way I approach this problem. Immediately I'm looking at it and going, oh my Lord, okay? But I do look at this cosine squared just like I did in the last problem. And I go, well, cosine squared on the card is 1 minus sine squared. Do you guys agree? Do you buy that? Okay? And then I'm going, well, what's 1 minus sine squared? Difference is squares. What's going to happen? They cancel out. Those two factors cancel, and I'm left with 1 plus sine x. Now, I don't know about you, but it's going to be a whole lot easier for me to get that right side to look like that 1 plus sine x than what it was above it. Okay? So, now I'm going to go to work where? Let's go to work on the right side. All right? What do you think? Where do you think I'm going to go? Because you guys know my mind now. I'm going to go old school. I'm going to go old school. So here I go. Cosine x over 1 divided by secant x minus tangent x over 1. Cosine x. I'm going to take away the 1s. Are y'all all right with me doing that? I'm going to take away the 1s and let's see what happens. What am I going to do with secant and tangent? What's going to happen now? What are you noticing? Talk to me. Common denominators. Common denominators. Let's keep looking. Cosine x divided by, I'm going to smush them together. What now? Ah, my favorite. Copy, change, flip. Copy. Now I'm going to put it back over 1. Change, flip. I'm getting there. I'm seeing the light at the end of the tunnel, y'all. What am I going to do? Yes, you are. Look at that. How do you multiply fractions? Straight across. What's cosine times cosine? 1 times this Binomial, is that binomial? Yes. We're seeing a light. I'm seeing a light at the end of the tunnel. What is cosine squared?
That's what you started with.
Shut up. Shut your mouth. Shut up. Look at you, Easter. Stop! Stop right there. We got the answer. That's what happens when I have to do this. I forget what I started with. Dang. There it is. Heck yes. Easter, look at you. Hallelujah. Could I have worked that out? Where was I headed with that? Differences, squares, cancel out the factors, and I would have had 1 plus sine x equals 1 plus sine x. Would it have been okay if Smarty McFarty back here would have not noticed that? Yeah, it'd have been fine. It would have totally been fine. I'm so glad you did that. I love you. I'm hugging you appropriately from a distance. Yes, hallelujah. Gonna have, yeah, questions. Oh, I'm so glad you saw that. All right, ready to roll on? I didn't make a mistake. Please. All right, so let's go there. 2 minus 1 over cosine, 1 over sine. Okay? I can multiply those together and just put them together. I also am going to have 2 fractions, so to speak. What? You just left the 2 alone? I'm going to feed you a steak. I have a gift card. Here we go. You foiled it out. Okay, because you got to work both sides on this problem. Did you foil it out before you changed it, or did you? Okay, so if we foil it out, we're going to have 1 minus cotangent minus tangent plus cotangent tangent. Ooh, that looks weird. Okay, all I'm doing is foiling it out. 1, 1, cotangent, tangent. Okay. Now, something's going to happen because this right here, let's think, cosine and sine over cosine. What's going to happen there? That changes to 1. Okay, so I'm going to have 1 plus, I'm going to work backwards here. Oh, what else is getting ready to happen on this left side? I'm going to combine my terms. My 1's right there. So I have 2 minus cotangent x minus tangent x. Say what? Change these to their reciprocals or their quotient identities. Okay? Now you need to step back and look. Common denominators on that left side. Because what we're trying to get, did y'all take it back to here or to here?
I didn't even change right now.
You didn't at all, okay? Hold that thought. Like denominators. So what did I multiply here? Cosine. Cosine times cosine is cosine squared. What did I multiply here? Sine. Sine times sine is sine squared. Look what's getting ready to happen. Okay? What's getting ready to happen is I'm going to combine these fractions. Pardon me? Is that good? Cut on. Don't erase anything, just hang on. Because it's probably going to come back. What if we did this? Hold that thought. Now, Morgan, right on. I want to copy this. You go. You just took care of that problem for me. Yep, because it's an equation, and I can. Very smart girl. Now I can factor out my -1. Oh, yeah. Look at here. Look yonder. Oh, looky, looky, looky. Look at you. I'm so proud of you. Now, look at the cosine squared plus sine squared. What is it, y'all? It's 1. It's 1. I love you. You don't even know. Now, here's another special comment. Remember your negative sign, think of it as a floating negative. It can either be at the top, at the bottom, smack dab in the middle, but it cannot be where? Both places. Because if it's in 2 places, then we're not talking about a negative number anymore. We're talking about a positive number. That made my life so much easier. Thank you. Thank you. Look at there. Oh, yeah, and is it okay that sine and cosine are not in the same order? Yeah, it's fine. Commutative property multiplication says I can flip them around. Other questions? Huh? Let me get through all these problems, and I'll look at it in a minute, okay? Because I need to get on with all the rest of them. Any others on this one? That's just number 8. Other questions? I love this stuff. Oh, no. No. Do I need to do number 9? Surely I don't need to do number 9. That's equal to 1.
Where's the -1 parentheses? What happens if it goes and sine squared?
Because that is 1. It's the Pythagorean identity. Yeah, card. Yep. Good. Very good, y'all. Do I need to do number 9? No. Number 10. Last one. Oh, I know you want to see it, don't you? Okay. Some of you are going to do some crazy things with this quantity squared thing, but you use the card from the get-go. Y'all got to figure out this binomial squared thing. I'm listening. Not now. Is that better? Okay. Make sure I got it. Sine squared. That's wrong problem. Tangent plus cotangent squared. Cosecant, secant. Because that's not the problem. That's the problem. Yeah. All right. So where did you use the card? You may have an easier. Who solved this problem all the way through? How many steps?
I solved the rate. So I had to solve that.
Okay.
I had 5 steps.
Did you FOIL it out? Okay, see? That's the problem I'm finding, and you guys are going to get those worksheets back today in that middle drawer. Actually, if you solve this problem, if you would pass those out while I'm doing this, that would be helpful to me. Yep. Okay. All right. Can I think about that? Legally? It looks like we'd be able to, but I wonder if it'd be a problem with principal square roots and that sort of thing. Let me check on that. Those of you who foiled this out, okay? Did you leave it as tangent and cotangent, or did you change it? You left it? Okay. Folks, you got to know that when you have a quantity squared, you are to write that quantity 2 times. You cannot, nor is it legal, to just say tangent squared x plus cotangent squared x. No, you can't do that. That's not right. That is not right. It is that quantity squared, that quantity times itself. Now, here we go. Foil it out. Tangent squared x plus tangent x cotangent x plus tangent x plus cotangent x plus cotangent squared x. Ooh. I have middle terms which are the same. Tangent squared x plus 2 tangent x cotangent x plus cotangent squared x. Okay, all I did was fold it out. That's all. That's the only thing I've done. But what's going on there with the middle terms? All right, this right here. Remember, tangent is sine over cosine, and cotangent is cosine over sine. What happens? Yes, ma'am.
All right. When you copied it down, aren't you just copy it down as cotangent?
The second time
Yeah.
here? No, because of the commutative property of multiplication. I just make them the same because I need to see them the same. But the commutative property of multiplication says that I can do that. Okay? All right, so now look. We've got 2 times 1 because all this stuff cancels out. All right, and see, now I've forgotten what we were supposed to get to. Cosecant, secant. Right on? Okay. Look what's going to happen. What'd you change? Did you change tangent? Okay, card. What was it? Tell me what it is. Minus 1 plus 2 plus, what's cotangent squared? Huh. Look what it is, folks. That's straight from the card. And then look, like term, like term, like term. What's negative 1 plus 2 minus 1? 0. And it gives me secant squared plus cosecant squared. Now, I'm getting closer. Then you got stuck right there. Why? All right, let's try this. Don't give up. All right. Where? From green to red. Okay. Negative 1 plus 2 minus 1, they all canceled out because that's 0. So I brought down secant squared plus cosecant squared. Okay. I'm where I need to be, but these are added and these are multiplied. All right. So now I just got to figure out, well, I got to make this work. If I'm adding these, then let's see how I'm going to make that work. Okay. I'm adding fractions. What do I have to have? Common denominators. Folks, it's going to be cosine squared x sine squared x, which means this numerator is going to be sine squared. Right on? Look what's getting ready to happen. Something's getting ready to happen. Which means cosine squared up here. Now when I smush that together, what's going to be? It's going to be 1. All right, I'm going to go on and put that step in there. If you want to jump to the next one, that's all right. I like writing on the board. Now, what was my original? Tag on it. Cosecant, secant. Cosecant, cosecant. Secant, right? Hey, what's this? What's 1 over cosine squared, folks? Secant squared. What's 1 over sine squared? Cosecant squared. Are they the same? Why are these two the same? What property? Commutative property of multiplication says that that's the same. You had to do another step.
No, I only had 3 or 4 steps.
Total. Nope.